everybody able to see that? It's a little dark. There. That's better. All right, it is about time to get going. So today we're going to cover 1.4, which really closely ties into the stuff that we talked about on Wednesday in 1.3. Because Wednesday is whenever we first really started discussing trigonometric functions, and I told you that, sine is like the inverse of cosecant and things like that, and we get to see that a little bit more here today in 1.4. And as crazy as it is, this is actually the end of Chapter 1. Chapters in the trig book are super short. Don't worry, you don't have a test just yet. We are going to cover a couple of sections of Chapter 2 before we actually have our test. Looking ahead, the test will not be this Monday, but the Monday after, which is the 6th. All of my tests will be pencil and paper, so you will get that as well. And I will make up my math lab practice test, though, as well. And my goal is, honestly, to have a paper and pencil practice test for you. That way you can see exactly how I'm going to lay it out, exactly what kind of questions I'm going to ask. I'm not going to be one of those professors that, we learn some stuff and then I'm going to go to the back of the book and pick the hardest ones that are like only word problems and only theoretical and super difficult, because that's not the point. I'm not here to trip you up. I'm here to help you learn how to do trig. So know that if it's shown up like on the homework or on a quiz or something like that, those are the kinds of problems that I'm going to pull from. I'm not going to pull extra super hard ones that you've never seen before. I had professors like that in college, and those classes sucked. Like, they just really did. Because you never felt prepared. Because you never knew exactly what was going to be on the test. So I want you guys to have confidence when you go into the exams that you do know exactly what's going to be expected. So today is 1.4, which is using the definitions of the trigonometric functions. And so the first types of identities or different types of formula type things we're going to use is using the reciprocal identities. And so first you have to understand what a reciprocal is. Hopefully everybody has kind of heard that word somewhere in their mathematical career. And the reciprocal basically is where you flip it. So it's as long as x doesn't equal 0, then the reciprocal of x is 1 over x. We do have to put that little stipulation that x can't be 0, because if x is 0, we get 0 in the denominator, and it makes it undefined, and that makes it a problem. So as long as x is not 0, the reciprocal just means you flip it. So if you start with a fraction like 1 over x, then going left also works. You would still just flip it, and then you would have the reciprocal of that. So the reciprocal identities are as shown. Sine theta is 1 over the cosecant theta. Cosine theta is 1 over secant theta. Tangent theta is 1 over cotangent theta. And then obviously the reverse of all of that is also true. Cosecant theta is 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. Not too horribly difficult, but you will use these as you move throughout the course. Today we're going to use these to help figure out the reciprocal values based on information that they give you in the problem. One of the most important things that does arrive out of these reciprocal identities is that when you multiply multiplicative inverses or reciprocals, which is what these are, you will always get the multiplicative identity, which is 1. If you take the number 2 and multiply it by 1/2, those are reciprocals of each other, and you will always get out 1. The same thing is true in trig with the trig reciprocals. If I take sine times the cosecant, then I'm going to get 1. If I take cosine times the secant, I get 1. If I take tangent times the cotangent, I get 1. And right now you're like, okay, that's not super interesting. But as we progress through, we're going to be proving different things about our trigonometric functions, and having these identities really helps us to simplify our proofs later on. Are there any questions about reciprocals in general in terms of algebra, or reciprocals in terms of what they mean here in trig? All right. Let's do a couple. Can I cover this? Are we okay? If not, it's okay. All right. Everybody was quiet. We're going to find cosine of theta if secant of theta is 5/3. So they give us one thing, but they ask us for something completely different. And we're going to use our reciprocal identities to help us figure this out. So even though I just took it off the screen, what we do know is we know that cosine theta is 1/secant theta. And if we know that, and we know that secant theta is 5/3, then that's like 1/5/3. And yes, it's a fraction and a fraction, and that is gross. So flip it to fix it. Does going from 1/5/3 to 3/5, does that lose anybody? The algebra that's involved with that. Yes, no. Okay, side note in case it does and you don't want to say anything. What's happening here is we have 1 divided by 5/3. That's what this says. Okay? But when you divide by a fraction, what happens is you flip it and you change it to multiplication, thus getting you back up to that 3/5. That's what's going on. Okay, let's do a sine one. Let's find sine if the cosecant of theta is the square root of 12/2. Based on our identities that we just learned, we know that sine of theta, let me slide up a little bit, is 1/cosecant of theta. So this is 1/the square root of 12/2. And I feel like I copied it down wrong. I did. This is supposed to have a negative out here, guys. Sorry about that. Add that little negative. So again, when I flip it, it's going to be 2 the square root of 12. But what happens? What am I supposed to do now? I got to rationalize it. I can't leave that radical in the denominator. So in order to rationalize it, that's where you take the top and the bottom and multiply it by whatever you have under that radical. So now I have -2 square roots of 12 all over 12. 2 and 12 both have a 2 in common, so you do want to keep simplifying it until you can't simplify it anymore. Let me slide up. So you have the square root, negative square root of 12 all over 6. Now 12 is not a perfect square, so it's not going to get simplified any further. But is there a factor of 12 that is a perfect square? 4, yeah. So you can keep simplifying and keep simplifying and keep simplifying until you get down here to negative square roots of 3 all over 3. A lot of you might be tempted to stop here or tempted to stop here. But make sure that you have completely simplified that as far out as it will go. A lot of times what's under your radical will not be a perfect square, so it's not going to completely go away, but there will be stuff that you can simplify out like we just did. So do watch for that. Your main squares are 4, 9, 16, those ones. So those are going to be the ones you're going to look for and ask yourself if those are factors of a number that's under your radical. Are there any questions on these two problems on how we use the information they gave us with our reciprocal identities to achieve our answers? Okay. The next bit is kind of just you taking some notes. This is good tables and information for you. I know you love tables. I use a lot of tables because they help me to stay organized. They help me to keep a lot of information in a small space. And so all that this right here shows you is we have a table form showing you pretty much the exact same information that this shows. And what it is it's the signs of the trig functions in given quadrants. Some of your homework and quiz questions simply state that you have a theta that lies in quadrant 3. Give the signs of the 6 trigonometric functions that will fall there. Some of you might be like, well, how is this helpful? Well, if I know that the tangent of my theta is negative, and I need to know where that lies in my quadrants or in my Cartesian coordinate system, there's only 2 places that happens, and that's in quadrant 2 and quadrant 4. So it helps me to eliminate a lot of different sections and narrow down where my theta can actually live. So the way that you read the table is that if theta is in quadrant 1, then it shows you what the value is, or the sign is, for each of our trigonometric functions. In quadrant 1, everything is positive, so that's nice and easy. And remember, the reason why this happens is because when we find our sine, cosine, tangent, and all those, is that we're using our x and y's, and that little radius, our hypotenuse. So our x's and y's are both positive in quadrant 1, thus all of our trig functions are also positive. And that's what's going on down here in this Cartesian coordinate system. In quadrant 1, I tell you that all thetas are positive, and it shows you that x is greater than 0, y is greater than 0, and r is greater than 0. So it's kind of giving you a little bit more information and more of a breakdown to explain why each of these trigonometric functions are either positive or negative. Will I ask you to ever regurgitate this table? No, I will not. Do I hope you can look at this table or look at this diagram and then be able to answer questions on whether or not a given angle is going to produce positive or negative trigonometric functions? Yes, I would hope you can do that. Does memorizing it help you in the long run? Sure, it does. But I'm not going to make you take a minute test over it or anything like that. Obviously, if you go back to rewatch the lecture video, these few minutes where you guys are just copying things down, I don't say much, and so it gets kind of boring. So feel free to skip ahead if you do have to rewatch that. Because I know that that's a real intriguing moment. Are we good to do a couple problems? Okay. These problems, even though there's no questions for you to look at or anything like that, what it's asking is it gives you a theta. It gives you an angle of 87 degrees in this first one, and it's wanting to know what quadrant does that lie in, and then which of our trigonometric functions are positive for this given angle. So the easiest thing to answer first is if it's angle 87 degrees, what quadrant does that lie in? Quadrant 1. Because remember, it goes 1, 2, 3, and 4, and then vertical is 90. So this is less than 90, so we're going to lie right over here in quadrant 1. And if we lie in quadrant 1, which of our trigonometric functions are positive? All of them. So a lot of your homework problems will either ask you something like that, and it's multiple choice, or they will give you like a true-false statement. For the angle theta equals 87, it'll say the cosine of that angle is negative. Is that true or false? And then you select true or false. So that's where this stuff kind of comes into play. All right, what about 300 degrees? Which of our quadrants does that lie in? Yeah, it's going to lay all the way over here in the fourth because this is 90, 180, 270, and it's over 270. So it's going to lie down here in quad 4. And if it lies in quad 4, which of our trig functions are positive? Cosine and secant. Those are the only ones that are positive. Plus. Our last one is negative 200 degrees. So what quadrant is that going to lie in? The second. Yep, and you are correct. So the way the negatives work is instead of going from our x-axis and going counterclockwise, we're going to go clockwise. And if you're going clockwise, and this is negative 90, negative 180, and since it's negative 200, you're going to be just over that, which is over here in quadrant 2. And if you are in quadrant 2, which are positive? Sine and what? Cosecant. So sine of negative 200 and cosecant of negative 200 would be positive. So you can be asked a lot of different variations of those questions. You could be asked for which ones are negative. You could be asked for which ones are positive. It could give you a true or false statement where it says all of them are positive or all of them are negative, and you just select from there. Questions? Okay, let's see another style of problem that's going to arise from these. We need to identify the quadrant or quadrants that satisfy the given information that they're going to tell us. So it's just wanting to know the quadrant or quadrants. We have sine of theta is greater than 0. That's a weird 0, sorry. 0. And we have tangent of theta is less than 0. Ugh. I write theta now, and so I can't write zeros. 0. Sine of theta is greater than 0. Tangent of theta is less than 0. So both of these things have to happen. So the way that I usually approach these problems, and you can do it a different way if you so choose, but if it says that sine of theta is greater than 0, that's where sine is positive. So which quadrant is sine positive? Yeah, so 1 and 2. Now tangent, though, has to be less than 0, so it has to be negative. So which quadrants are negative? 2 and 4. So then which quadrant satisfied both? 2. So quadrant 2 is where sine is greater than 0 and tangent is less than 0. It's almost like a puzzle, is how I see it. Does that make sense, how we figure this out? Again, if you ever have questions, make sure you just yell at me, because I'm going to be looking a lot of here-ish, not a lot of here-ish. Oh, no. Don't do that. All right, for this one, we have cosine theta is less than 0, and we're going to have secant theta is less than 0. So both of these are going to be less than 0, or a negative. These little equal signs with the little arrow things, that's just how I draw my arrows. It's not like a mathematical symbol or anything. I'm just saying cosine of theta less than 0 implies what quadrants? Like, where is cosine of theta negative? In quadrants 2 and quadrants 3. And secant of theta is less than 0 in which quadrants? 2 and 3. So which one or 1 satisfies both? 2 and 3. So you can get more than one quadrant that does work. You could also get where none of the quadrants overlap and none of them are true. So that's why I like to write out to the right of them which quadrants are included. Sorry, I wrote 3 and 3 on that last one. 2 and 3. Any questions at all on how we figured this out? Okay. Here's a little bit more notes. Just a little bit. Oop, let me get it centered on here. There we go. Ranges of the trig functions. So remember that the range of any algebraic expression, trigonometric expression, or anything like that, the range is your output. What can you get out of your sine, your cosine, your tangent, your cotangent, your secant, your cosecant, and so on and so forth. And they actually have different ranges or intervals that you can get as your possible solutions. And so I have given these, that's the same information in set builder notation and in interval notation. I will say interval notation is usually, for me, easier to see what values actually fall within the range. But I gave you both. So set builder notation is always going to be with curly brackets because that's how you indicate a set. And the way that you read this is that it says the set of y such that. This big vertical bar means such that. And then it says the absolute value of y is less than or equal to 1. So what this actually means is that the sine and cosine of theta, of this trig function, has to lie between -1 and +1. The sine of theta can never be 2, or -10, or 12, or any other number. It has to fall between -1 and +1. So some of your homework problems are asking questions like that, and they're stated like the next set of questions we're going to encounter where it says possible versus impossible. Is it possible that sine theta equals +2? And you'd say, well, no, it's not possible because sine theta has to fall between -1 and +1. So that's an impossible statement or a false statement. For tangent theta, cotangent theta, it says y, it's a set of y such that y is an element of, this weird little e means is an element of, and then this weird looking r is a symbol for the real numbers. So I guess I can write that one here with some words so that you can see how it actually works. Set of y such that y is an element of the real numbers. This is one of what I think is kind of neat about math, is it really is its own language, and we can fit this entirely long sentence into like these 5 little symbols. And I think that's pretty cool. Do you have to memorize that? No. Because again, I like the interval notation better, because the interval notation tells me that any value is going to work for tangent theta, cotangent theta. It can be anything between negative infinity and positive infinity. Our last 2 trig functions, they kind of go in pairs, as you can see, is our secant and our cosecant. And this is where our y, our absolute value, has to be greater than or equal to 1. So what does that mean? It means it can't be anywhere in between negative 1 and 1. It has to be greater than or equal to 1. So if I had a half, if I said that secant of theta is a half, that wouldn't work, because that falls in that section in between negative 1 and 1. What's kind of neat about all of this is if we take the range for our sine and cosines and we join it, like if we unioned it with our range from secants and cosecants, we would actually get the range for tangent and cotangents. So it's kind of neat that it all pairs up there. And the style of problems that you will have from this given information really are just like true and false, only they word them as possible and impossible. And we're going to do 3 of them. 3 seems to usually be a good number of practice problems. And they're listed right there, if you can see that. It says sine theta is 2.5. Is this possible or impossible? Why? Yep, it is impossible. Sine theta has to be between negative 1 and positive 1, so this is not a true statement. It's an impossibility. Again, these are mostly like matching. I was looking at your homework, and sometimes though, one of the reasons they word it as possible instead of impossible instead of true false is because true false, it's like there's 2 options. Possible versus impossible, they can give you 4, 5, 6 different options, and then you have to use the right logic as to why this one is possible versus not. So if I knew that this is impossible, and I look at my listing and there's 3 different options for impossible, then I need to read those 3 options to make sure that I select the right one. Because it could say, it's impossible because it could be this, or it's impossible because it's this. So you do have to know just a tiny bit more in this impossible versus possible than a traditional true and false. But I was looking through them. They're not difficult. Just make sure you look for that. As soon as you know whether it's possible or impossible, you eliminate half of your problems, like half of the choices. So I guess I'm saying that don't just immediately pick the very first one that matches in terms of if it's impossible. All right, the next one says tangent of theta is 110.47. Possible or impossible? Why? Right, it's a number. And if it's a number, it's going to work. I guess the only way that would be impossible is if they gave you like an imaginary number or something like that. Because as long as it's a real number, it works. And no, I don't think we do trig with imaginary numbers, so don't freak out about that. And for C, we have secant of theta equals 0.6. Possible or impossible? Why? Right, it's going to fall in this gap right here between negative 1 and positive 1. And so it is impossible. Any questions on the impossible versus possible versus the range that we're getting out of our different trigonometric functions? going to slide it up a tiny bit. I'll leave all the impossible possible right there, though. We're going to do another style of problem that's going to come up. It says, suppose theta is in quadrant 2, and sine of theta is 2/3. Based on just this information, we need to come up with the other trig function values. I will tell you, I think on your homework, when it does this, you do still have to type in like the one that they gave you. So it gives us the sine of theta. We will still have to put that in as an answer later on in our answers at the bottom. So what we know is we have theta in quad 2, so that's over here somewhere. We don't know anything else, but it's over here. And we know that sine of theta is 2/3. Okay, so based just on that information, what else do we know? Or what is the next trig function that you think would be easiest to find based on this information? Yeah, cosecant. Cosecant will be the next one that's easiest to find because it's the inverse of sine. Okay. Who remembers from, I don't know, sometime this week, what sine, I guess it was Wednesday, sine is what over what in terms of x, y's, and r's? It's y over r. Okay, which means that this is r over y. That's not super helpful. But what is helpful is I'm going to draw just a regular triangle that would kind of show up if we were in quad 2. Because look, if we're in quad 2 here, we would draw our triangle down like this. So I'm going to draw a really generic one over here just because I like to think of my trig functions in terms of a triangle. It helps me. And we'll put theta in here. So if I know my y value is 2, and I know my r value is 3, how do I come up with my x value? The Pythagorean theorem. That is absolutely right. Because 2 squared plus x squared would give me 3 squared. So I find, whoops, that you can't see, I find that x is the square root of 5. Really, it's plus or minus. And usually we just think about the positive, but this is where it comes into play what we learned about earlier. Okay? If we are in quad 2, and this is our x value, is our x value in quad 2, is it positive or negative? It's negative. So this is negative the square roots of 5. But now that we have this triangle that is completely labeled and we know all of our side lengths, we actually can do all of our trig functions straight off of that. And that's one of the reasons why we fill it in. Because cosine was x over r. Sorry, I have it zoomed in so far. I don't know what's on the screen and what's not. So x over r would be the negative square root of 5 over 3. And then the inverse of that, the flip, would be secant. Always remember to rationalize those denominators if you need to. Tangent theta is y over x. Oh, sorry. I'm still zoomed in. Cotangent theta, it's just the inverse of tangent, but I'm not going to inverse the last simplified bit. I'm going to go up to the original. because then I don't have to rationalize the denominator twice. So when they give you the information of letting you know what the quadrant is and then letting you know what one of your values are, you can use that information to get your triangle set up and thus determine your other sides. The one thing you do have to be careful on is usually you're missing one of your side lengths, and you're going to have to pay attention to which quadrant you're in to make sure that you either have it positive or negative according to what it's supposed to be. Because if not, then all of your signs are going to be slightly off as you're computing. Are there any questions on this? Okay. We've got a couple more identities and 2 more problems. I'm going to leave it. You can see the next problems, but I'm going to write them down on the white paper so they show up a little bit better. So Pythagorean identities and quotient identities. These are just more tools in your tool belt that are going to help you as we can progress on in this class into doing proofs and comparing different trig values. I can zoom in a little bit more. So sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. As we move on, we will have opportunities to kind of prove these. If you want to see the proofs for these, they are in your book. I just didn't want to spend the time writing them all out. They are interesting. And we do some like 2-column proofs. Maybe you've seen those way back when in high school in either a trig class, or really you encounter those in a geometry class in high school, where you have a column that runs, like a line that runs in the middle, and you keep manipulating one side of your equation until you get it to look like the other side. And we do that as well in this class. And these are some of the things we will use to help us with those proofs. Our quotient identities are also helpful, where if we put sine over cosine, it's actually the same thing as our tangent. Cosine over sine is then equal to our cotangent. So those are helpful as it comes to us manipulating these problems around. While you're writing that down, I'm going to prep the next 2 problems, which again, I know you can see one of them, so don't cheat. Ready? I can leave at least some of it up there for a little bit. We need to find sine theta and tangent theta, given that cosine theta is -3, or the square root of 3 over 4, and sine theta is greater than 0. So I guess it's nice to note some of this from the very beginning. If we know, like I like to keep track of what we know. We know cosine theta is -radical 3 over 4, and that's our x over our r. So we know that. And if we know that, what else do we know? We don't know anything about our sine, per se, and we don't know anything about our tangent, per se. Sorry, what is always positive? Yep, the R is positive. Do we have something that maybe we just saw a few minutes ago? Was it a few minutes ago? Or is it in a previous section? It might have been in a previous section. Let me look. It's in a previous section. I think it was from Wednesday. On Wednesday, we saw something that looked like this. Do you remember this at all? And it actually correlated to circles, and I told you it would pop back up later. Does anybody remember this? Because this is how we find the distance, basically, for the radial length, or the radius length there on our hypotenuse. Do you remember this at all? So if we know that we can take our x and our y value to find our r, and if we know cosine, we actually know 2 of the 3 values for this given equation. We know the x and we know the r. What we don't know is the y. But we can figure that out using algebra. Because if our x value is this negative radical 3, we can plug that in over here. We don't know the y, but we know r is 4. So negative square roots of 3 squared is just going to be 3. Y squared equals 13, so y equals plus or minus the square root of 13. Now, what can we tell from this? We don't know what quadrant we're in, but we know that sine has to be greater than 0. Right? So where is sine greater than 0? Which one? First and second quadrant, okay? First and second quadrant. But look, if this is negative and this is positive, then what else do we know? Huh? We are going to be in quadrant 2. And if we're in quadrant 2, and our cosine is negative, then is our sine, what's it going to be? So if our sine is positive, and since r is positive, and sine is y over r, yes? And if sine has to be positive and r is positive, then y has to be positive. That's kind of where we're getting at. So we don't have to have this plus or minus. We can just say it's positive radical 13. So now really we have the exact same thing we had earlier with our triangle, only we didn't draw a triangle this time. We have our x value, we have our r value, we have our y value. We can figure out any trig function that they ask us to at this point. But the ones that they asked us for was sine and tangent. So if sine is y over r, well, the y we just found was the square root of 13. The r was 4. There's nothing left to do on that one. Tangent theta is y over x. Y is radical 13. The x is the negative radical 3. I don't know. I'm just going to write x. We do have to rationalize. Sorry, I keep wanting to write radicals when I don't need them. 39 has no perfect squares in it, so it would stay that way. So you do end up using a lot of the information from these various tables to help you work through these problems. You just sometimes won't even realize you're doing it. The deduction on whether or not your y is going to be positive or negative actually stems from the table of signs that we had on the earlier page to help us understand whether or not that value needs to be a positive or a negative. Let's do another one. This one's going to tell us which quadrant we're in. This one we need to find sine and cosine of theta. And it tells us that tangent is 4 over 3. And it tells us that we are in quad 3. Based on our Cartesian coordinate diagram earlier, if we are in quad 3, I can't spell quad, If we're in quad 3, that means that our x's are negative, our y's are negative, and our radius is positive. Negative, negative, positive. Tangent theta is y over x. If y and x are both negative, that's how we're going to get out a positive value at the end. So what this tells us is that our y value is -4 and our x value is -3. And if we know our x and our y, we can come up with our r. Because x squared plus y squared equals r squared. This is our triangle. It's Pythagorean theorem. So we have 9 plus 16 equals r squared. We have square root of 25 equals r, so 5 equals r. And it says r has to be greater than 0, so r is positive. Based on this information, we now know our x, we know our y, our r is 5. So we can find our sine theta, which is y over r. We can find our cosine theta, which is x over r. Y over r would be -4/5. X over r would be -3/5. So we're using Pythagorean theorem. We're using the identities. We're using all of the information that you've had so far in these last 2 sections. And I know it's a lot of information. It is. But the more you play around with them and the more that you do these problems, you have a better, deeper understanding of how all of these relate to each other. Are there any questions? I know it's a full one today. Okay, that's it. That is it for 1.4. This week we did cover 1.2, 1.3, and 1.4. So those are the 3 assignments you have due on Sunday by 11:59 p.m. So hopefully you've been working on those as you've been going through the week. Remember, do not wait until 10 p.m. Sunday night to pull open those quizzes. That is a very bad idea. If you have questions at any point, send me an email. Again, if you email me at 11 o'clock at night, you probably won't get a response back till the next morning. There is a sign-in sheet. I know somebody already left, so hopefully they'll email me later. Please sign in before you leave. I will have the regular sign-in sheet on Monday where you will just initial when you come in or out. I hope you guys have a good weekend. I will have the lecture video posted this afternoon around 2:30.